Currently, I'm working as a geologist in UCOS project, that is Uttarakhand Council of Science and Technology, and my post is project assistant. Here I am because of I'm just going to create a lecture series over the mm, understanding of subject, that is geomorphology. So, what is geomorphology? Today, we will learn about some topics that those we can cover within this presentation. So basically, the topic which we will focus that is introduction of geomorphology and fundamental concepts of geomorphology. So guys, let's start. Introduction of geomorphology. So basically, geomorphology is a branch of geology and geography both. And and geology both are comes under earth sciences. Geomorphology, that is also called physical geology, is the branch of geology or geography within which we study about the physical appearance of the earth and the physical landscape those are found on the surface of earth. So basically, geomorphology is consists of three words: geo plus morph plus logy. Geo means earth, morph means physical appearance, and logy means study. The study of physical appearance of the earth is geomorphology. So basically, if you talk about landscape or landforms, those are found on the earth's surface. Basically, there are three types of the landforms, or three order of the uh, landscape or landform. Those are found on the earth's surface: first order, second order, third order. First order are the landforms, that is ocean and continents. These are the basics. And after which we have second order, those develop over first order: mountain, plateaus, lake, faults, rift valley, etc. Then we have third order. Third order is glacial valley, river valley, karst valley, cirques, canyons, gorges, terraces, edungs. And these are erosional feature, means these are developed after erosion of the second order of landscape or landforms. Then we have drumlins, eskers, floodplains, natural leaves, delta, sea beaches, sand dunes, stalactite, stalagmite, etc. These are depositional feature. Um, Means they are developed after deposition of the eroded material in some places, and then they develop into a particular landform. So these are the basically these process, all the kind of the landform those are developing on the earth's surface are due to two type of the agencies, or we can say two type of forces those are working in the earth: for endogenic force and our exogenic force. Endogenic force is the force that works from the inside of the earth and develops some feature on the earth's surface. Okay, androgenic force may be tectonic force, volcanic forces, or convection currents, whatever. And then we have exogenic forces or exogenic agencies. Exogenic agencies are like weathering, erosion, denudation, whatever. Okay. Now, if you talk about fundamental concepts of the geomorphology, what are the fundamental concepts of geomorphology? Fundamental concepts of the geomorphology are given by Sir W.D. Thornbury. Uh, these are nine concepts. Okay, let's come to first concept of the fundamental concept, that is geomorphology. Concept number one. Concept number one is the same physical process and laws that operate today operated throughout the geological time, also not necessarily with the same intensity as now. What this concept means? This concept means the physical processes those are working today, they are also working in the past, but the intensity of their work is different. With As we travel in the time, the intensity of the working of any geomorphological process differ, but the process is same, that is working in past and present. So this principle is also known as principle of uniformitarianism, that was postulated by James Hutton in 1785. That is a Scottish geologist, James Hutton. He gave another concept, that is present is key to past. That also means that whatever is present in the present time, that is also tells about the what is present in the past. Okay, and there is concept, in another word we can also say no vestige of beginning and no prospect of end. Okay, so if we talk about example that justify this concept, so we all have heard about the Pleistocene glaciation. Pleistocene glaciation is the activity at that time in the Pleistocene. Glacial activities at their peak was at their peak. Nowadays, glacial activities are also there, but the intensity of the glaciation is not as much as in the Pleistocene. So, from this example, we can understand that geomorphological processes are same, but the intensity of working is different in the different time scale. Okay, so let's come to next concept, that is concept number two. Geologic structure is dominant control factor in evolution of landform and is reflected in them. So geologic structure is dominant control factor. Means whatever the geologic structure is having a dominant control factor that plays a crucial role in evolution of landform, and they also reflect this in the landform that is created. Means if there is some landform that is if we observe some landform, so whatever the landform that is fault, whatever, we can say that this geological structure having a crucial role in the evolution of this landform. Means we can we can understand this by some examples. Okay, the geological structure have a control factor in evolution of landform. Okay, and that reflected in them. So geological structure here means nature of rock. It may be igneous, it may be metamorphic, it may be sedimentary, and arrangement of rock. Then we have rock characteristics. Arrangement of rock means bedded, folded, faulted, domed, whatever. And rock characteristic, faulted, jointed, permeable, impermeable, chemical characteristic, whatever the mechanical characteristic. So first we cover the nature of the rock. What is the nature of rock? So basically we have three kind of the rock: igneous rock, metamorphic rock, sedimentary rock. So if you talk about, we will start from igneous rock to understand this concept. Think we have a vertical lithology consisting of two incompetent layers, and between them there is a competent layer. Basically, what is incompetent layer and what is incompetent layer? Competent layer is the layer that is hard as compared to incompetent layer, and incompetent layer are softer as compared to competent layer. So basically, competent layer are the layer, those are composed of igneous, metamorphic, high grade metamorphic rock basically, and more or less sedimentary rock. Okay, so if we have an igneous lithology between two sedimentary lithology, and we have a bed of igneous rock between two sedimentary rock, and we can say we have a dike. We have a dike. Uh, okay, we can say we have a sill, because dike is the something geologic igneous structure that have a concordant relationship. Sorry, discordant relationship with the sedimentary beds. But sill is a igneous structure that have a concordant relationship with the uh, sedimentary beds, or we can say straight of the rock, beds of the rock. Now we have a sill that is tilted, or we can say having tilt nearly 90 degree or something 70 degree, that is present between two competent layers of sedimentary rock, incompetent layers of the sedimentary rock. Now, some weathering erosion, weathering activities occur on those rocks or stratas, and we will see after some time what happens. The competent layer will be less eroded compared to incompetent layer of the sedimentary rocks, and the sill will be appear on a ground as a less eroded competent layer. And when we observe it, it appears some like musas, beauties, such kind of structure develop over there. So now here, Mesa Betway are the geologic structure having those are appear from a sill, having a control factor, dominant control factor in evolution of landform. Okay, and they reflect their presence in them. Now, if we talk about sedimentary rock, so we have one kind of sedimentary rock, we all heard about it, limestone. Limestone is a chemical, we can say, chemical sedimentary rock, or in a different, we can say it is non-clastic sedimentary rock. Non-clastic sedimentary rock or chemical sedimentary rock that is composed of CaCO3, that is calcium carbonate. When it comes in contact of the water, or we can say so any solution, it the CaCO3 comes into solution and remove out and make some large depression there. The large depression are are in the sequence, that is sinkhole, shallow hole, dolines, ovalas, polges, etc. These are the depression those formed over igneous, limestone, that is a sedimentary rock. So such kind of structure develop over a limestone lithology, or we also say it crust lithology or crust topography. And these are erosional feature of crust topography. If you talk about, if you talk about what are the depositional characteristic of the crust topography, so we have some cave structure. When CaCO3 dissolve in the solution, and the solution becomes saturated with CaCO3, and there is no space for further saturation. At that point, at that point, what happened? CaCO3 start their precipitation in the form of cave feature such as stalactite, stalagmite, halactite, halakmite, calc tufa, cave pillars, etc. These are the cave feature, and these are the depositional feature of limestone lithology. All these structures are playing a crucial role in evolution of a landform, and they reflect them itself in the whole lithology. Okay, or landscape or landform, whatever. If you talk about metamorphic rock, what are the metamorphic rock? Metamorphic rock basically it is an intermediate rock. We also said that what we have within a rock cycle, we have primary rock, that is igneous rock. Then we have secondary rock, that is sedimentary rock, and within between them we have intermediate rock, that is metamorphic. When what happens when any igneous rock got weathered, and the weathered material got eroded down and settles into some uh, settling basins or any space where they found a place to get settled down and deposit. After some time, after a long process of cementation, compaction, and lithification, it converts to a sedimentary rock. When sedimentary rock under deep-seated condition goes through temperature, pressure, and chemical activity of fluid, it convert into a metamorphic rock. And after some time, when this metamorphic rock also experience a high temperature pressure condition, it also convert into a we can say magma. Okay, or that time it plays a it it also when it converts to a lava magma under a deep seated condition, it now this lava is the primary source of an igneous rock. Okay, so rock cycle is I am not saying that sedimentary rock cannot convert it to a igneous rock. It can be, because within nature everything is possible. But rock cycle is basically what kind of cycle is going in a uh, geology, or we can say within the petrology. So this is the rock cycle, but we are talking about metamorphic rock. So metamorphic rock, basically metamorphic rock have three grades: low grade, medium grade, and high grade. So on the basis of their durability and resistance to weathering and the basically weathering and erosion, we classify them into or the nature of the minerals those are present within the rock, and their durability to further and resistance to weathering and whatever the process those are acting from outside of the rock. And we can say they are how how this kind of uh, they are affecting the rock. Okay, so low grade metamorphic rock, basically the rock those got weathered easily, shale, slate, etc. Medium grade rock, phyllite, sorry, yeah, cyst and phyllite, and then we have high grade metamorphic rock, that is nice. Okay, there are various kind of metamorphic rock. Those are found in the, and there are various structure. Those are developed after of metamorphic rock, and they also play a dominant crucial role in evolution of landform, and they reflect their presence in landform also. Okay, guys, let's come to arrangement of the rocks. Okay, arrangement of rocks. Okay, arrangement of rocks. We have folded. First, we can say we have folded landforms. Folded lines, whatever. When what happens when a lateral compression occur over any strata, horizontal strata, what kind of strata, inclined strata, vertical strata, but there is a lateral compression, or we can say the compression acting on the both side of the rock. Okay, what happen after some time the rock get buckled or squeezed into a fold. That kind of structure is called fold. Okay, so in the initial stage of the development, there is a development of terralized drainage pattern over that kind of rock strata. So when some kind of rock got folded, there is a development of subsequent. We can sorry subsequent not. We can say there is a sequential development of anticline and synclines respectively in a one by one manner. After some time, what happened when there is a development of, because when within nature what happens, what when such kind of structure develops, so we have some streams, those are flowing in the earth surface. They find their path. They find their path. After when they find their path, there is a there is a phenomena that is called inversion of relief found within such uh, sequence of anticlines and syncline. What happens, the anticlines becomes anticline valley after erosion, and syncline become syncline ridges after erosion. So such kind of structure develops over folded lithology of anticlines and synclines, and this is due to inversion of relief. We can say inversion of relief means there is some relief, and after some time, due to erosional activities, there is inversion of relief. Okay, guys. Now we will comes to the structure. We have faulted structure. Faulted structure, what happened? Faulted. When after we will understand na, why in a sequence sequential movement that will that may be easy to you. What happened? We have a folded structure. Let's say we have a folded structure, and further there is a further there is a compression acting on that fold structure on the both side of the fold limbs. What after some time there will develop a fracture on the hinge zone of that fold. Okay. Now, after development of the fracture, if further lateral compression acting on that fold, what happens along that fracture plane, the fault blocks on the both side of the rock blocks on the both side of the fracture got displaced along that fracture plane, and that is called a fault. That consists of two blocks, hanging block and foot block. And basically we have three kind of basically um, we have three kind of fault: normal fault, reverse fault, thrust fault. So normal fault is the fault where along the fault plane hanging wall is up thrown and foot wall is down thrown. Okay, but we have within the reverse fault, what happens, hanging wall got appear as a down thrown wall, and a foot wall appear to be up thrown wall. What happens in thrust? Thrust is same as reverse fault, but the angle between fault plane and the horizontal is less than 45. In that case, it is called thrust. Okay. Now, uh, at the fracture plane along which the displacement of the rock happens, that is also called fault plane, and the fault plane that is visible is called fault scarp. After erosion we say it scarp, fault scarp. So we have three type of fault scarp: consequent fault scarp, Obsequent fault scarp, recusant fault scarp. Obsequent fault scarp, when there is a when we can say along the fault plane there is a erosion, and it is a normal fault. In that case, we set it consequent fault scarp. Then we have obsequent fault scarp. We can say at the case of normal fault or thrust fault, we have a visible fault plane and it got eroded at that time. The fault scarp is called obsequent fault scarp. And after, we can say we have recusant fault scarp. At the case of uh, mm, obsequent fault scarp, when the base level of erosion all fall down more, at that case we say it recusant fault scarp. So guys, uh, further we have domed structure. Domed structure, what happened? It upwrapping of the, if we say there is a upwrapping of the earth crust, and it emerges out in the form of inverted bowl. That structure is called domed structure. Over domed structure, we have a drainage pattern that is common, that is radial drainage pattern. Means rivers are or streams are originating from the top of the domed structure, and they are flowing across the radius of the dome and in all direction. So such of the they are such kind of structure is also playing a dominant crucial role in development of the landform, and they also reflect their presence. If we talk about unicline and homocline structure, look, when a rock strata that is tilted at a uniform dip, that kind of structure is called unicline and homocline structure. Okay, uh, what happen if we have alternate hard rock, soft rock, and there is erosion activity occurs? Same. So where the erosion is more, they develop strike valves. Strike valves where a stream flows, and the remaining part that is less eroded and appearing as a ridge, that is called casta. Okay, we can say also river valley sides. Okay, now we comes to rock characteristic. It may include mechanical chemical composition of rock, permeability impermeability of the rock, joint fault fracture resistance, rock weathering, etc. Okay, and these are the geological structures. Those play dominant control factor in evolution of landform, and they also show their presence. Okay, guys, now we comes to next concept, that is concept number three. We have a concept number three, that geomorphic process leave their distinctive imprints upon landform, and each geomorphic process develops its own characteristic assemblage of land. What this concept means? Basically, we have a lot of geomorphic process. Those are working on the earth surface and giving carving out the earth surface into different type of landform. So each geomorphic process leave their distinctive imprints upon the landform. Means if any what kind of geomorphic process, that is fluvial, fluvial, aeolian, glacial, coastal. We have what kind of geomorphic process we have. If it is working on any landform, it will develop its own characteristic assemblage and its imprints upon that landform, particular landform. Okay, so that this concept means. So basically, we have geomorphic process, that is erosion. If you talk about, first we have erosional work. Erosional work that can be done by air, that can be done by a river, that can be done by glacier, and that can be done by the some dissolution. In case of crystallography, that can be done by water or any soluble uh, solution, any solution that can make soluble the solutes. Okay. If we talk about erosional work, we have if we have a river. In case of river, we have some erosional work that is done by river, that is in very in season, that is deepening of valley widening, that is widening of the valley floor, okay, and pothole drilling of some cylindrical holes over the riverbed. Within crystallography, as we previously I told you that When it comes, limestone comes into contact of any solution, or we can say water. Commonly we have water. It dissolves out the CuCO3 and leaves the depression there in the form of sinkhole, swallow hole, dolines, pools, ovalas, etc. Okay, so such kind of topography are done by the geomorphic process, that is crust. Uh, that is done by the geomorphic process, that is solution. Okay, of water. Now move further. We have depositional work. Depositional work done by river. In case of river, what happen when a lot of erosion or done by the river, there is a form of the sediment that comes in the form uh, as come in the form of river load with the river, that is every class of the sediment, that is clay, silt, sand, boulder, cobble, pebble, etc. Okay, so these are the loop that comes with the river, and when the gradient of river and the velocity of river decrease down, these are the sediment, those are deposited in the form of beaches. Okay, sand beaches along the river side, and in the form of small islands, we can say also that pattern, braided pattern. Okay, alluvial fan, alluvial cone, a lot of depositional feature find by the river. Okay, now, if you talk about depositional feature that is done by the happens in the crust topography, as I already told you, stalactite, stalagmite, calc tufa, when when the CaCO3 got saturated within the solution, and there is no point of further saturation, it got precipitated in the form of cave depositional feature, that is stalactite, stalagmite, halactite, halagmite, tufa, calc tufa, cave pillar, etc. These are the geomorphic processes that develop their own characteristic assemblage over landform and leave also their imprints over land. Now we move to next concept. We have concept number 4, that is, as different erosional agency act on the earth's surface, they produce a sequence of landform having distinctive characteristic at successive stage of development. Okay, what happens in the what this concept basically means? If you if I repeat this concept and then I tell you what is the message that is we understand from this concept. Look, as the different erosional agencies act on the Earth's surface, there is a produced of sequence of landform having distinctive characteristic at successive stage of the development. Means if whatever the erosional agencies those are acting on the Earth's surface, they produce a sequence of landform. Means uh, erosional activities, whatever these are, they are producing a sequence of landform, and at the successive stage of development, there are some distinctive characteristics that resemble that particular uh, stage is mm, is the we can say that particular stage is reflecting some sequence. Okay, so we can understand it very good by the development. We can say some examples should be there that will make it understandable easily. So, guys, if we talk about, we have basically what happens when river starts its course from glacier to ocean. In its path, in initial stage, we have youth stage of the river when the gradient and velocity of the river is high, and basically it forms in the hilly regions. But when it enters in the plains, when it enters in the plains, the gradient and velocity of the river decrease down. That stage, intermediate stage, is known as mature stage, and at the time when river is about to drain into the ocean, that type of stage is also called as old stage of the river. So there is some characteristics those from which we can identify that what is youth stage, what is mature stage, and what is old stage. So what happens? What happens uh, in the we can identify the river that is it is in the youth stage, that various minor stream or tributaries that those are within a catchment area are going to be join a mainstream river, and they will develop a drainage pattern sorry dendritic pattern. What is dendritic pattern? We can we have all we have observatory from the bottom to upward. What happens, there is a single stem, but as going to upward within the tree, we the stem of the tree develop into a various small stems or branches. Such kind of pattern is called dendritic pattern, and that is also seen, that can be also observed in case of the when tributaries are joining the mainstream in the hilly region. That is called dendritic drainage pattern. At that case, what happened, in the youthful stage of the river, we find a convex slope of the river valley side in youthful stage, and a lot of valley incision is there. As compared to valley widening, valley incision is there, pothole drilling is also there. So that is the characteristic that characterize a youthful stage of the river. Okay. Now we have mature stage. When the river reaches to a plain in the intermediate stage, what happens at that time? Valley widening is there. Valley widening is there, and depositional feature what we have: natural leaves, sand beaches, alluvial cone, meandering of the river, and such kind of various kind of depositional feature we observe, and those are characteristic of the mature stage. And also one thing, in mature stage the valley side slopes are almost straight. But what happens when later on the river enters in the old stage? What happen, and it is about to drain in the ocean? At that time the valley widening is at its peak. Okay, and the river divides into numerous of distributaries. Again we have some kind of, in the initial stage we have tributaries, now in the old stage we have distributaries. What are distributaries? When the river breaks down into numerous small streams before draining in the ocean. Okay, that kind of that kind of small streams are also known as distributaries. And such kind of old stages also known by anastomosing drainage pattern, when lots of small islands they get develops in the between the midway of the river. Okay, anastomosing feature is there. Okay, deltas are there. Such kind of the such kind of mm, feature are telling about the old stage of ravine. So we can say, as the different erosional agencies acting on the earth's surface, they produce a sequence of landform. That is right, having distinctive characteristic at successive stage of development. That is also right. As we go from the youth to old stage, we have different landscape. Those are resembling the river having following some path that is in sequential format. Okay, now we comes to concept number five. Concept number five, that is geomorphic scale is significant parameter in interpretation of landform development and landform characteristic of a geomorphic system. Okay, so geomorphic scale is significant parameter in interpretation of landform development and landform characteristic of a geomorphic system. Okay, and in other words, we have landscape is function of time and space. So basically, this is concept is saying that we have a geomorphic scale, and geomorphic scale can tell about landform development and landform characteristic of a geomorphic system. Whatever the geomorphic system we have, geomorphic scale tell about the landform development and landform characteristic both. What are the geomorphic scale? First, we have to know that we have basically two type of. From the other words, we can say, we can understand landscape is function of time and space. Here we have those two scale, that is temporal scale and spatial scale. Temporal scale is scale though that is telling about time, and spatial scale is telling about the space that is consumed by a geomorphic system. Okay, now we have, so any landscape that is developing over the earth surface, okay, is a function of time and space. Means the time consumed by it to develop in a landscape and the space that is required to develop in a particular landscape. So basically we have three types of temporal scale: macro scale or cyclic time, that is ranges in millions of time years; mesoscale and graded time, that ranges in uh, thousands of years; and now we have micro scale or steady time, that is ranges in hundreds of. If you talk about spatial scale is nothing that tells about the extent of the landscape. Means it is in kilometer, it may be in the meters, whatever this extent that a landscape will cover, that is a spatial scale. So basically, that means any geomorphic geomorphic scale can tell is a function of time and sorry, any landform is function of time and space. Okay, now we have concept number six. What is concept number six? A simple geomorphological equation may be envisaged as vehicle of for explanation of landform as follows. Geomorphological equation that we can say is a vehicle for explanation of the landform. Okay, we have equation that is capital F is equal to F small f PMDT. What is this concept and equation means? Basically, the concept is saying that this is equation is a vehicle that tells about the landform or explanation of a landform. How? That is landform F is function of process P over material M in time dt. Simply this. That no more explanation needed in this concept. Okay, so landform F is function of process P over material M in time dt. This equation means this uh, statement. Okay, so basically our concept number six is justified. Now we talk about concept number seven. Complexity of geomorphic evolution is more than simplicity. Complexity of landform geomorphic evolution is more common than simplicity. So basically, any geomorphic evolution or geomorphic process or any geomorphic system is basically a function of more than one process, or it may be consist of one process. But basically, it doesn't happen most of the time. It consists of more than one process. So this process wants to tell that complexity of any landform is more common than simplicity. Whatever the geomorphic evolution happening in the landscape or within the earth's surface, okay, its complexity is more important. Its complexity is more common and important than simplicity. There is no simplicity, but because there is complexity is more. Okay, so we can say we have simple landscape, compound landscape, monocyclic landscape, polycyclic landscape. So landscape, we are saying simple landscape. Simple landscape that that divide of complexity means we can say easily by this landscape is function of one process. Okay, or it has fashion more than only one cycle of erosion. So easily we can say this is a simple landscape over the. We can understand that only one cycle of erosion is there, and only uh, one process uh, is there behind this landscape. Now we talk about compound landscape. Compound landscape where more than one geomorphic process is responsible for the landscape. That is compound landscape. Now we have monocyclic landscape. That's that landscape that faces only one cycle of erosion. That is monocyclic landscape. And now we have polycyclic landscape that faces polycyclic landscape are the landscape that faces more than one cycle of erosion. Okay. Now we have concept number eight, that little of the Earth's topography is older than Tertiary and most of it no older than Pleistocene. Okay, so this concept basically means that over all of the topography of the Earth, only little of the Earth topography is older than Tertiary. Means Tertiary say more than older than Tertiary. and these are now older than Pleistocene. Okay, so uh, Tertiary period, which span from 66 million year to 2.6 million year ago, lot of geological processes there that shape the planet. Okay, that is uplifting of mountain, formation of valley, carving of river system, and the Pleistocene epoch that began around 2.6 million year ago, ended around 11,700 million years ago. Mm, Pleistocene period, or we can say epoch. Pleistocene epoch basically characterized by numerous glaciation and interglaciation period. Okay, within that period, a lot of erosion and deposition of work is done by the glaciers. Okay, now if we talk about uh, what happens, this statement basically wants to tell that whatever the topography we have, little of the topography of the earth. Okay, these are older than tertiary but not older than Pleistocene. Okay, so within this we can say all of the topography of earth is older than tertiary, behind 66 million year ago, but after, these are not older than Pleistocene. Pleistocene means 2.6 million year ago. Okay, so now we move to concept number 9. Each climatic type produces its own characteristic assemblage of the landform. Okay, so basically whatever the climate is there, that produce its own characteristic assemblage of land. We can say within coastal region we have the landform that reflect that the landform are basically belonging to coastal region, and the landform those are developing in the fluvial region, we can say that reflect in them. So whatever the landform we have, that that tells about the climate that prevail there, means within we can say glacial topography, we can say the cold climate prevail there. In the desert region we can say there is a less humid climate is there. Within fluvial region we can say humid climate is there. So all climatic condition have a crucial role in development of the landform. So, guys, we have completed the fundamental concept of the geomorphology. Those are 9 fundamental concepts of the geology given by W.D. Thornbury with an explanation. Hope you will like this and understand this, and it will be helpful to you. We will go in more depth of the subject. So, guys, uh, let me give me permission to close this topic, and after this, we will meet you with a new topic that will be surprise for you. Okay, but I have a clue for you that that concept that topic will also under a geomorphology. Okay, guys, thank you.